to Cambridge Chemistry channel. In this video I will discuss the question number 2 of paper 3. It is the question of regarding rate of reaction. In this experiment you will investigate how the rate of reaction between sodium thiosulfate and hydrochloric acid is affected by the concentration of the acid. When aqueous thiosulfate ions react with hydrogen ions in any acid, a pale yellow precipitate of sulfur is formed. The ionic equation for this reaction is given below. Sulfur dioxide, sulfur and water are formed when sodium thiosulfate react with hydrochloric acid. And you know that concentration is one of the factors which affect the rate of reaction. By increasing concentration, the rate of reaction is increased as particles become crowded and have more frequent collisions per unit time. So in this experiment we will observe the how concentration affects the rate of reaction. Fa4 is 0.10 mole per dm cube sodium thiosulfate. Fa5 is 0.20 mole per dm cube hydrochloric acid. Method: record all your measurements in an appropriate form in the space below. Experiment 1. We are doing 3 experiments in which different concentration of acids are used, and observe the factors above the effect of these concentration on the rate of reaction. In first experiment, use a larger measuring cylinder to transfer 40 centimeter cube of Fa4 into the 100 centimeter cube beaker. 40 centimeter cube of Fa4. Fa4 is 0.10 mole per dm cube sodium thiosulfate. So transfer into the 100 centimeter cube. To transfer, rinse the larger measuring cylinder thoroughly with water, then add 30 centimeter cube of Fa5. 30 centimeter cube of Fa5, that is of 0.20 mole per dm cube hydrochloric acid, to the beaker and start timing immediately. Stir the mixture once and place the beaker on top of the printed insert page provided. Printed insert page are white. Place beaker on the white tile, and on the printed insert page draw the cross. So stop timing as soon as the precipitate of sulfur makes the print on the insert invisible. So when sulfur is formed, obviously it becomes invisible. Record the reaction time to the nearest second. Empty and rinse the 100 centimeter cube beaker. Dry the outside of the beaker. Ready for experiment 2. Experiment 2. Rinse the larger measuring cylinder, then use it to transfer 40 centimeter cube of Fa4 into the 100 centimeter cube beaker. Use a small measuring cylinder to add now 10 centimeter cube of distilled water to the beaker. Use the same measuring cylinder to add 20 centimeter cube of Fa5 to mixture in the beaker and start timing immediately. Stir the mixture once and place the beaker on top of the printed insert page provided, and stop timing as soon as the print on the insert become invisible as soon as the sulfur is produced. Sulfur is yellow colored solid, and sulfur, as soon as sulfur is formed, this cross will become invisible, which you made earlier before starting the experiment. Record the reaction time to the nearest second. Empty and rinse the 100 centimeter cube beaker. Dry the outside of the beaker. Ready for the experiment 3. In experiment 3, carry out the reaction using a mixture of 40 centimeter cube, 20 centimeter cube distilled water and 10 centimeter cube of Fa5. Now Fa5 become 10 centimeter cube and distilled water 20 centimeter cube. Measure and record the reaction time to the nearest second. Now make a table like this. This is experiment 1, 2, 3, and volume of Fa5 30 centimeter cube, volume of water is 0 centimeter cube. Similarly, volume of Fa5 20 and volume of water is 10 centimeter cube. Time per second is 78 and 96 second. In this experiment 144, in after 144 second, cross placed on the printed insert page is invisible. So these are the result. Now the rate of reaction can be represented by the formula below. Rate of reaction is equal to 1000 over reaction time. Use this formula to calculate the rate of reaction for experiment 1 and 3. Give the unit. Rate of reaction for experiment 1 is 12.8, unit is second inverse 1, and rate of reaction for experiment 3 is 6.94, unit is S minus 1. Calculate the initial concentration of hydrochloric acid in the reaction mixtures in the experiment 1 and 3. In experiment 1, concentration is 0.20 while volume is 30 centimeter cube. So first convert it into dm cube, that is equal to 0.030 centimeter cube. 30 centimeter cube volume is used and concentration, and over here in experiment 2, 10 centimeter cube which is converted into dm cube, that is equal to 0.010 decimeter cube. So the concentration of this is 0.0857 mole per dm cube, and this is 0.0286 mole per dm. Now in this, first of all calculate the moles and afterwards the concentration. So this is the mole and volume. You know that the total volume of the solution in both experiment is 70 centimeter cube. So that is 40 plus 30 is equal to 70 centimeter cube. So the concentration will be 0.0857 in case of experiment 1 and 0.0286 in experiment 2. This is the mole of experiment 2, and total volume is the same in both cases. So the concentration is 0.0286 mole per dm cube, and in this case 0.0857. So initial concentration of HCl in experiment 1 is 0.0857, while the initial concentration of HCl in experiment 3 is 0.0286 mole per dm cube. How is the rate of reaction affected by the concentration of hydrochloric acid in the mixture? So rate of reaction increases with increase of concentration as the particles become crowded and have more frequent collisions per unit time. Predict how the reaction time measured in experiment 1 would have been affected if the experiment had been carried out using 0.20 mole per dm cube sulfuric acid instead of 0.20 mole of HCl. The time will be shorter for sulfuric acid as sulfuric acid has greater concentration of hydrogen ion. Sulfuric acid has 2 moles of hydrogen ions. Okay, the sulfuric acid has 2 hydrogen ions while hydrochloric acid has 1 hydrogen ion. So when we use sulfuric acid, reaction is increased as there is more number of moles of hydrogen ions. HCl has 1 mole of ions while sulfuric acid has 2 moles of ion. Predict how the reaction time measured in experiment 3 would have been affected if the experiment had been carried out in 250 centimeter cube beaker instead of 100 centimeter cube beaker. Explain your answer. Reaction time will greater due to less depth of solution in 250 centimeter cube beaker. So 250 centimeter cube has less depth than the 100 centimeter cube of the beaker. So that's why experiment had been carried out in 250 centimeter instead of a 100 centimeter cube beaker. Explain your answer. So this is the why, because less depth of the solution in 250 centimeter cube beaker. Hopefully you get it